Hello. In this video, we're going to be talking about the lateral area and the surface area of a cone. So if you're ever asked for the lateral area, what you're being asked for is the area of this part of our cone. So without a bottom or without a top. So just this part. And of course, you know, it goes back as well. So the area of the whole thing going around. This is such a lovely picture. All right, so that is the lateral face of our cone. So now if you're asked for the lateral area, the formula for lateral area, and I'll call it L for short, is lateral area is equal to pi r L. All right, let's make sure we know what R means and what L means. R is the radius of the cone, so that is our R right here. And L is the slant length of the cone. So if I were to take a ruler and measure from the vertex, from the tip-top vertex, all the way to the bottom along that slant, that is our L. All right, so if you're then asked for the surface area of the cone, that's a slightly different question. All right, so now we have another cone here, and if you're asked to find the surface area of the cone, so now you're not only being asked to find the lateral area, which as we already know from what we just spoke about, is the area going around that curved surface, and of course also in the back. So you're not only being asked to find that area, now you're also being asked to find the area of the circle at the bottom. So now the surface area is both things combined. So for the formula for surface area, can you see that? I think so. Surface area is the lateral area, pi r L, plus the surface at the bottom. And we already know that the bottom is a circle. So the area at the bottom is going to be pi r squared. So those are the two formulas that we need in order to figure out lateral area and surface area of a cone. So now let's look at an example. Okay, so in this example, we're being asked to find both the lateral area and the surface area. So I'm going to go ahead and start off with the lateral area. And so I know that lateral area, let me use a different color, lateral area is pi r L. All right, so we do have we don't have the radius yet, but it's super easy to find. Radius is half of the diameter, so our radius is 5 centimeters. And we don't have our slant length yet. But again, it's not so hard to find. We know that when we put the radius down, it creates a right angle with our height, which is 12. And so we have a right triangle here. We have 5 right here. We have 12 right here. And we can either do Pythagorean theorem or use Pythagorean theorem or use the fact that we know that this is a special triplet, a Pythagorean triplet. It's a 5, 12, 13 triangle. All right, so I'm hoping what I'm saying is making sense. And so that's 13 centimeters or length. So our lateral area is equal to pi times 5 times 13, which gives us 65 pi, and that's approximately equal to 204.2 centimeters squared. All right, so that's how you find the lateral area. And if you want the surface area as well, which we do in this case, then you'd go ahead and you'd do surface area, S, is equal to lateral area, which we just found, plus pi r squared. So I'll do the whole thing again, just so you get used to seeing it. So pi r L plus pi r squared. And I'll move up here. Pi r L, as we know, is pi times 5 times 13 plus pi times 5 squared. And when you work that all out, you should get 90 pi, or 200, approximately, actually, 282.7, I believe, centimeter squared. All right, and so that's how you find the lateral area and the surface area.